Okay, welcome everyone. My name is Choroba. I'm from Prague. I usually have my employer on the third line, but despite what my badge says, I have no employer. I quit the last day of the previous month. And I will today talk about Marpa, what it is and why or when it is needed. So, what is Marpa? But before we start, I probably should explain this weird name of the module. So it's named after Marpa the translator, which was a Buddhist teacher in the 11th century. And he brought Vajrayana to Tibet, which is some kind of a Buddhist teaching. But the important part is the translator. So Marpa is, or basically Marpa R2 is a parser module written by Jeffrey Kegler. This R2 stands for release 2. So it's a parser module. What is a parser? A parser is a program that takes text as its input and outputs some kind of a structure following rules of a grammar. And Marpa is a module that makes it possible to write parsers in Perl. I'll show you a classic example. The grammar is presented in a so-called Bacchus-Naur form. And it passes or generates, because it can work both ways, mathematical expressions of arbitrary complexity. So how it works, for those of you who don't remember or don't know, I'll show how it works for a simple mathematical expression. So we have 7 plus 2 times 13. Should be 3, sorry. At the beginning, we recognize 7, 2, and 3 as numbers, which we can see. We can see here in the grammar, and then we proceed to factor, and for the 7 we'll proceed even higher in the hierarchy to term and to expression. And now we have like 2 possible ways what to do. Either use the rule for the expression plus term. If we add a term at the top of the factor on the 2 column, and then we can form an expression at the top, but then we do not have any rules to apply for the remaining column with the number 3. So this is not the right thing to do. So we instead use the 2 factors to form a term, and then we can get to an expression by applying the plus rule. So by using this expression, term, and factor, so-called non-terminal symbols, we also have the precedence of the operators implemented correctly. That's how it's usually done. And here is the same thing implemented in Marpa. And you can see that it's pretty similar. In fact, it can be exactly the same with, I think that you just have to use quotes for the operators. But yeah, so there is one thing that's there that we didn't have in the classical example. Let's just say it's some kind of a cargo cult for the moment. Then we have something called actions. So we can, each rule can be accompanied by an action. And actions are in fact implemented here at the bottom. And you can see, for example, if you look at the add, it has expression plus term. The plus is in parentheses, which means it's not sent as an argument to the action. So we have the expression and term. And what we will do with it, we'll just add them together. So it's pretty straightforward. And the third difference is I used named terminal symbols. They are explained or expanded at the bottom. This is, in Marpa, it's called L0 grammar. And it's basically some kind of like a tokenizer for the parser. Okay, but Marpa can do better than that, because if we think about mathematical expression, we usually do not think about factors and terms. We just know that there is some kind of precedence of the operators, and that's it. And in fact, in Marpa, you can use this. So instead of a single vertical bar, you can use a double vertical bar, which says the rule on the left of the double vertical bar has a higher precedence. So here we say that the multiplication has higher precedence than addition and subtraction. So it makes it shorter and closer to how people usually think about mathematical expressions. So, and it makes it much easier to add further operations. For example, if we want to add exponentiation, I made just two added just two empty lines, and we'll fill them with this simple thing. So we now have exponentiation. You can see that there is a strange thing on the very right, which says ASSOC right, which just means that the associative nature of exponentiation is different than the one of the other mathematical operations. We add the missing action, which is again pretty straightforward. So yeah, it makes it pretty easy to do this. Without priorities, we'll have to introduce a new non-terminal symbol. I called it EXP here. And again, complicate the rules so they have to appear in the correct order. Okay, I want to continue with this example a bit more. So currently, the number is recognized as anything containing a dot and digits, which is not exactly correct because it can, for example, accept something like this, which to me seems more like an alligator emoji. So we can use this vertical bar in the L0 grammar as well, and we can describe number pretty easily, so it can recognize any number that Perl can recognize. Or not any, like it doesn't recognize hex numbers, but yeah. Okay, so let's now make it more interesting and let's add variables to our grammar. Maybe I should say, at the beginning I said that the parser assigns a structure to a string. In fact, we are not assigning any structure, we are directly evaluating the expression, but it's just a small detail. We could build some kind of op tree and then evaluate that, but mathematical expressions are easy enough. We don't have to compile them, we can interpret them easily. And it's true for variables as well. So we'll introduce variables, and we'll introduce a print command to show the output. And again, it's rather easy. So we'll now have not just an expression, because we can have several expressions. We'll have a program. A program is just a sequence of statements separated by semicolon. A statement can be either an assignment or a print command. Assignment is just the variable name, equal sign, and expression. And print takes a list, which is a list of comma-separated expressions. Again, the interesting thing is the variable. So it starts with a character, a letter, and is followed by alphanumeric characters. Okay. And we have to add the new actions. The interesting ones are the store and interpolate, which handle the variables. So we'll keep a hash of variable names, and the value of the variable will be the assigned value. So let's now add strings. So we want to be able to print something like the result is, and then the value. We'll not be able to assign strings to variables to make it easier. So it's pretty easy. A list now can contain a string, and string is just something that has quotes on the ends. And we also need to say that a string doesn't contain a quote, and that's it. So no escaping in this case, to make it simpler. And the last step is the crucial for this talk, to show you what Marpa can do. We can make semicolons optional. And it's, in fact, pretty easy. So we can now process something like this. And I have a test file that verifies that it really works. I can probably show it at the end of the talk. So what Marpa provides it's called Ruby slippers. And it is an interface to the parser internals. And it makes it possible when the parser fails, you can ask it what symbols were expected at the time. And the parser tells you, and you can tell it, well, okay, so let's pretend this symbol was there, and let's continue. And the parser goes on. And this is something that's not present in most other parsing libraries and algorithms. But it complicates the code a bit. So what we had previously was this. So grammar is some kind of an object that takes the rules, which is basically the string with the Backus-Naur form. And we just tell the grammar to parse, and it returns the value. So it's pretty easy, and we send the input in. With Ruby slippers, it's a bit more complex. So we'll now have something, and I now don't remember the correct pronunciation of RECCE, I don't know. Recce? Okay. I think it's a military slang for recognition. Recce. Okay. So it's another object that represents the parser, basically, and we can, so we now have to proceed in smaller steps in order to be able to interact with it. So what we do, we tell it to read the input. It tells us what position in the input it has, and while it's not the end of the input, we loop, And we basically step after, we step if it cannot proceed, or we, not step, but we, like the read stops and we go into the body of the loop. And we ask whether semicolon was expected. So there is this terminals expected method, which tells us, it just returns an array reference of the expected terminal symbols. And we can tell it, read this like seam or terminal symbol. And I added a warning so I could like verify that's working correctly. And if semicolon is not expected, we are in a situation where the expression was wrong. We don't know what to do, so we fail. And it works as expected, and it parses this string correctly and prints 3. Okay. I'll later publish my slides, and this slide is kind of like a long list of links to various forum replies where I show Marpa to people. It's usually people saying, we have this JSON-like format, but it's not exactly JSON. What should we do with it? How can I parse it? So I usually can create a grammar for them and show them how to do it. But I think it won't be available exactly right after the talk because the SSH problems here. Okay, so to conclude, you can use Marpa whenever you need to parse text using a context-free grammar, which basically means whenever there is a possibility to parse it at all, because for anything more complex, you might be in a deeper problem. And it's extraordinarily helpful if you need to interact with the parser. If you need to, which makes it also possible to parse much more complex languages than just context-free. So thank you. This will be the URL once I upload the slides. Thank you. And are there any questions? Yep. Is there a microphone? Or?
Thank you. I would like to ask about the efficiency issue. Is there an underlying C library in Marpa, or is Marpa implemented fully in Perl?
Marpa is written in C, so it's rather fast.
Can you give some examples of real-world applications? So, I mean, I've come across this many times, looked at it and thought, oh shit, I'm not doing this. So we have another half an hour. Can you show one or two of those? That'd be great.
Let me... I have to connect to the internet, right? So for example, let's see what this is. Okay, so I'll have to see the question first. Okay, so someone has, I'll make it larger. Okay. Someone has this format, which is kind of JSON-like, but not exactly. And they want to create a Perl structure from it. And it's probably possible to use regular expressions, but it seems pretty recursive, so not so easy to do it. Someone showed how to do it using various like other techniques. Yeah. Yeah. And what I did, I just wrote a grammar. Again, you can see the list of the actions. It's pretty short and straightforward, and that's it. I also forgot to mention there is this default action. I usually write it at the very end when I can count the number of occurrences of each action, and the one that occurs most often is then the default one. So it makes it even like easier to read. And it's usually first or second or something, because these are like the most common actions. But it depends on the format of the input. So basically, this is just like full of examples how to use it. I don't think any of them contains something that's like Marpa specific. It's probably just grammar, and maybe this one is kind of different. This time it's Stack Overflow. So, yeah, and the problem that the person had was that they wanted to have a keyword that would not be possible to use as a variable name or something, if I remember correctly. And they were not able to stop the parser from recognizing it as... Yeah, that's what some languages do. Like you have a reserved keywords that cannot be used as anything else. So, and I wasn't able to, like, there is no way how to do it directly, or I was not ever aware of any. But it's possible to make it part of the grammar. Like you can stop if something happens, and if you are not in the correct state, you fail. So. So there are some examples here.
Okay.
Yep.
I don't know if it also answers my question, but what motivated you to look into Marpa?
Okay, so there is a project which is called Karel, which is like a toy programming language for teaching programming, and I wanted to try to write a compiler for it, and I used Marpa to compile it to some kind of a structure that's then interpreted when the robot moves in a maze. I talked about this, I think it was in Cluj, so the talk is somewhere online. But I think it had problems with the microphone, so maybe it's just the slides. Yep.
So you showed us how to read bad JSON. Any chance you have something for bad XML, like XML that has a negative ampersand stuck in the middle of it?
Like, for example, here there is strange XML JSON-like format with multi-line attributes. Again, we probably need to see the original question. But Marpa is a rather large project. Is it? No, it's not there. Is this the input? No. What's the input? Oh, so it's just this. Okay. Yeah, so it does some kind of a computation on a recursive structure again. So it's probably not exactly in bad XML. There is a parser for, and I'm not sure whether it's HTML and XML or both of them at the same time on the Marpa pages. So Marpa people write parsers for various known formats. to show off.
Yeah, I've looked at Marpa several times, and yeah, the thing that fascinates me is that you can get, if you have an ambiguous grammar, you can get all the possible parse trees. But I've never found a use for it, maybe because I'm sheltered and only get data that has an unambiguous grammar. Have you found a use for that, or?
That sounds pretty like theoretical to me. I don't think that it's like something you need in practice, because usually if there is some kind of data, it probably means something and doesn't mean several things at the same time. So yeah, but it's probably good for like debugging a new grammar. So you can find like a missing rule or missing condition somewhere if you are getting more than one like interpretation, and you can like see what the differences are. Okay? So thank you all.